Welcome to Chapter 3, Lesson 8, Solve Systems of Equations Algebraically. Our learning target objective for this lesson is to solve systems of equations, you guessed it, algebraically. Our one vocabulary word and last one for this chapter is substitution, an algebraic mod that can be used to find the exact solution of a system of equations. As always, you may pause the video and continue once you are ready as you write down your definition. Okay, we're going to jump into examples. Solve the system of equations algebraically. Y equals x minus 3, y equals 2x. What it means by substitution is we can substitute one thing in for another if it's equal to each other. So let's look at, we have y equals x minus 3 and y equals 2x. So y equals something, y equals 2x. So if y equals 2x and we have this y up in our first one, and y is y, we have 2x is y, so we can plug in 2x right there. So we can make it 2x equals x minus 3. Because they're equal to each other, now we can solve for x. Once again, now we're looking at variables on both sides of the equations, just like chapter 2. So we have to get x by itself and solve for that. So let's subtract an x from both sides. 2x minus 1x gives us an x. These x's cancel out. That gives us negative 3. So x is going to equal negative 3. But remember, our solution has an x and a y. So now we know our x is negative 3. How are we going to get our y? Why? Because we're going to substitute our negative 3 in for x into our equation now. Doesn't matter which one you can do it. You can do it either one. Let's take our y equals 2x. We know x equals negative 3 now, so y equals 2 times the negative 3. Y equals 2 times negative 3 is negative 6. Negative 6 is our answer. Now if we want to double check ourselves, we can plug in anything over here to double check. Let's do y equals x minus 3. Let's just plug in the negative 6 in for y. So we have negative 6 equals x minus 3. We're going to add 3 to both sides, get x by itself. X equals our negative 3. There we go. We double checked. There's our answer. So our solution for the first one is negative 3, negative 6. Always make sure you have your 2 points as your solution. Don't just stop at 1. You have to substitute that first answer back into the equation again. Okay. Now looking at this one, we have y equals 3x plus 8 and 8x plus 4y equals 12. I always like to, if you have a choice, always take the one where y equals by itself. It makes it so much easier. Y equals 3x plus 8. That means we're going to take in our next one. We're going to take this y out right there, and we're going to plug in our 3x plus 8. So it's going to give us 8x plus 4. Now the y is gone, so we're plugging in the 3x plus 8 in there equals 12. Okay, now we're getting back to some stuff in chapter 2 with equations. Once again, we need order of operations, a parenthesis. First look inside, we have 3x plus 8. Can't do anything inside yet, but we do have that 4 sitting on the outside. That means we're multiplying everything inside the parentheses by 4. So here we have 8x plus 4 times 3x gives us our 12x. Plus positive 4 times a positive 8 gives us a positive 32 equals our 12. Now, before we get anything moving from left to right, we're going to see if we have any combined like terms. We have an 8x and a 12x. We can combine those. The 32 and the 12 we can't because they're on the opposite sides of the equal sign. So the only thing we can add together is 8x plus 12x gives us our 20x plus 32 equals 12. Now we have our two-step equations, which we did in chapter 2. We have to get x by itself, so we're going to subtract 32 because you do the opposite. That leaves us our 20x equals a negative 20. Divide each side by 20. X equals negative 1. Okay, that's the first part of our answer. Now we're looking for our y. So now we can just take our -1 and plug it in for any one. We'll plug it into the top equation. So we're going to have y equals 3 times the -1 now. That takes place at x plus 8. So 3 times -1 is -3 plus 8. So y is going to equal -3 plus 8 gives us 5. And 5 is your answer. So again, you can always plug those back into the other equation to double check your answer and to see if it's right, but it is -1 and 5. Again, any questions, please circle anything you're having problems with. As I said, chapter 2, you're going to be using the equations a lot, and here they come right back at you in chapter 3. Let's move on to a real world example. A total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. Write a system of equations to represent the situation. Solve the system algebraically, not verically. Interpret the solution. Okay, so we have a couple of things here. Total of 75 cookies and cakes. So we know something equals cookies and cakes equal 75. That's cakes equal x, cookies equal y. We know, add those all together, our y plus our x equals 75. There's one. And then there were 4 times as many cookies donated as cakes. So we have 4y, which is our 4 times cookies, equals our cakes. Whoops, that's not right. Cookies equals 4 times cakes. There we go. So we 4 times the cakes equals as many cookies were donated. There's our 2 equations. All right, so we have our 2 equations. Now we're going to solve them algebraically and just find out our solutions. So we can again substitution. We have a y. The y equals 4x, so we can plug in the 4x for our y up above. So now we have 4x plus x equals 75. 4x plus 1x gives us 5x's equals 75. X equals 15. So let's plug back in. We're going to substitute the 15 in for x. So now we have y plus 15 equals 75. Subtract 15 from both sides. That's going to give us y equals 60. So interpret our solutions. Our x's, going back to the very top. That knows there was 15 cakes, and then there were 60 cookies donated for the fundraiser. Any questions? Please write them down, review the videos. We will be going over more story problems, real world examples in class.